Peacock mantis shrimp!
To catch an audience's attention, you need to have a good hook. Luckily, the subject of our vodcast has the best right hook in the animal kingdom. The peacock mantis shrimp can throw a punch the same speed as a .22 caliber bullet, which it uses to kill its prey and defend its home. Peacock mantis shrimp are one of the largest and most colorful species of mantis shrimp, with their bodies covered in shades of orange, red, green, and blue. They grow to be 2 to 7 inches long and can live up to 20 years. Peacock mantis shrimp are active predators who mostly prey on hard-shelled invertebrates such as gastropods, mollusks, and crabs. As previously stated, they use their raptorial appendages to punch and kill prey. Unlike many other marine creatures, peacock mantis shrimp reproduce via internal fertilization. Once fertilized, the eggs are laid and carried on the female's front appendages, where they are protected and kept clean. To communicate with each other, mantis shrimp use vibrations known as stomatopod rumbles, which are mostly used to fend off other shrimp as they are highly territorial. Because of this, they usually live solitary lives and only meet to mate.
These mantis shrimp mostly reside in the shallow areas of the Indian and Pacific Oceans. Here is a world map where the yellow on the map indicates where mantis shrimp are found. They usually live in U-shaped burrows that they have dug, abandoned burrows, and occasionally in coral reefs. Mantis shrimp experience spectral sensitivity. Shorter photon wavelengths such as blue light are absorbed by the top of the mantis shrimp's eyes, while longer photon wavelengths like red light are registered by the bottom of the eye. In 2019, a study was done at our very own University of Minnesota. In this study, a research team discovered that the photoreceptors of larval mantis shrimp have structures that reflect and transmit light into the light-sensitive cells at the same time. These reflecting filters are also thought to help detect bioluminescence. This study was a breakthrough, and to show this, here is a quote from Catherine Feller, lead author of the study and researcher at University of Minnesota. While many animal eyes use either reflectors or colorful filters to tune their vision, this is the first example of a visual structure that simultaneously reflects and filters a band of light in a living creature.
A mantis shrimp punch can hurt a lot, but you know what else hurts? Cancer. This research consisted of benchtop animal experiments and human study to test whether the camera would work in a surgical operating room. The benchtop experiment were used to evaluate whether the various fluoriform emissions and excitation spectrums could be distinguished from one another. In the animal experiments, the goal was to understand if 2 tumor-detecting probes were superior compared to just one of the probes. In the human study, it tested lymph node mapping near infrared fluorescent dye in comparison to 2 dark-colored dyes traced with a radio tracer. The image system created was based on the mantis shrimp eye due to their unique and highly developed eyes that allow for a maximum number of photons to contribute to the surrounding area in a single glimpse. This new technology would allow for image-guided cancer surgery in patients and has been able to distinguish healthy and cancerous tissue 92% of the time in mice. The camera functions by using fluorescent-labeled sentinel lymph nodes, which indicate whether cancer has spread from its original region and are then detected with the sensor to diagnose breast cancer. This bio-inspired imaging sensor allows for surgeons to see where the diseased tissue ends and the healthy tissue starts. Shown here are before and after images of the removal of lymph nodes from a patient with breast cancer. This visual system wouldn't impede the surgeon's work nor slow down the surgery. In comparison to past options, the camera would allow for less time under anesthesia, a higher chance for a complete tumor removal, and a quicker recovery time.
Worldwide, 1 in 3 people are affected by cancer, with surgery being the primary treatment provided to patients diagnosed with localized cancers. In a majority of hospitals today, surgeon's touch and eyesight are the primary components used during surgical procedures. This can oftentimes result in uncertainty when distinguishing between healthy and cancerous tissues and create a large sense of distrust in the medical community. Significant interest has been shown towards the further efforts of the development of imaging systems. The use of these image-guided surgeries can result in a decrease of patients' possible medical expenses, as well as the ability to improve surgical outcomes and increase overall quality of life. Crustaceans are important in all areas of the world. They hold great commercial, recreational, geological, and of course biomedical values as well. This marine camera was designed after the eyesight of mantis shrimp. It shows how they see the world and is used, as the picture says, to help research learn more about how different animals, specifically shrimp, octopus, and cuttlefish, use polarized light in their natural habitats. Many similarities have also been found between the color receptors in a mantis shrimp's eyes and satellites who use similar functions to scan the world and send information down to Earth. Because of these similarities, designs for more advanced satellite imaging can be further developed, as well as other forms of visualization processing that scan objects of interest, rather than just seeing a two-dimensional image like our eyes and other normal cameras. And who knows, maybe you'll even find one of these devices at a prawn shop someday.